Okay, good morning everyone. Actually I posted a couple of questions. How many hours were there for last week? Like 3 hours, 4 hours, 5 hours? No, it's not that long, I guess. Yeah, it is a shorter one. Again, what can I think? So anyway, so we stopped from question number 44 of that recording. What I'm saying is like even if you couldn't do these questions at home, next day just participate class nicely because once we start full papers, it is going to be really alright. So, mind you, okay, so let's start from question number 45. Is this a question? Yeah. I guess only this medium is different. Okay, so the name is as, they want us to draw this structure for the name. Uh, this is the structure and this is the maintain. Okay, they are asking this name starting from carboxylic acid and this is the main chain. So the name become 3-amino 4-bromo 2-ethylpentanoic acid. 3-amino 4-bromo 2-ethylpentanoic acid. Okay, couple of conversions are asking. Just conversion, they are asking to convert. There are no any other rules. Just they say if the conversion are too longer, they are not giving maximum or the highest marks. Okay, NO2. Yeah, this is NH2, but you have to join only one single bromine. If you just go with converting NO2 to NH2 by tin concatenate sodium hydroxide excess, and then even when you add in just bromine, this is going with the electrophilic substitution for these three orthopada positions. So make it අපි catalyst එකක් දැම්මොත් මොකද වෙන්නේ? Then the reaction is so vigorous it can break this one or otherwise it can make complex here. So that no marks for this method. This method is wrong. Before converting to this NH2, in the meantime, if you find any other place that we can join this NH2 to benzene ring, let's move with that. Okay, and one method NH2, NO2 to NH2, and then we can save NH2 by adding acid halide. Then this is joining COR, and this NH, this part is just maintaining. This is we are decreasing actually the activity. Now these amides are ortho-para-directed but less active, so you can join just one single bromine here to para place, and then you can reveal this NH again by adding any acid or any base or whatsoever. That is one of the methods. Always remember that you can just protect these groups, either ester or either amides, then you can take it back. Or the second method, NH2, N2Cl, we're just going to remove that. We're just going to convert it to bromine. And first bromine, and this is ortho-para director, then nitration, then NO2, and then back to NH2. Both methods are correct. Both methods are correct. Copy this. Okay, so here the method is iron converts to green R, then add one carbonyl, and then OH to Br to Cn. But if you go like this directly, can you do this? No, because there are no Western reactions on halo areas. Remember that? Don't. You can't do that. Okay. We are Sinhala. Okay, this one indicate how to distinguish the two compounds given in the following pairs chemically. This is directly bonded NH2, so this is like aniline. Benzylamine, but this is like aliphatic because CH2 is joining to NH2. This is like primary amine and this is aniline. So we can distinguish between aniline and primary amine. So add sodium nitrate Cl, a lower temperature 0 to 5, then NH2 become N2Cl, add phenol separately to obtain products, then disonium plus phenol makes this colored compounds, and orange color dioctane, B, no color change can be. We are doing an again this because CH3 and H2, this is become CH2OH. That's all with B. Okay, part B1. This mechanism, we did this mechanism continuously. Only difference is, remember we did this how many times for this MCQ questions. Only difference is this time we have this CH2 group, but this is symmetric, and this is bromine also is like symmetric, so you can join any bromine. This is pushing electrons away from the bromine molecule, so the Br plus electrophile is joining, and this is C plus, this is giving this delta bonding, coming to this bromocation, but that is unstable, so that this is trying to drag electrons from this carbon, so that the Br minus is joining exactly this lone pair or exactly the negative charge. You have to show this initial point of donation of electrons. Gaseous Br2O, Br2CCl4 can be used. Gaseous Br2O, Br2CCl4 can be used. Okay, moving on. Again, conversions. This actually is very famous. We did already a couple of times for normal theory. You just need to join one single carbon. Either you can go with the Friedel-Crafts alkylation, joining one CH3, one carbon, oxidize with potassium permanganate and reduce with lithium aluminum hydride ether and water to this. Or otherwise, bromine, Grignard, this one carbon carbonyl, and then hydrolysis. Both methods are correct. Carbon dioxide, water, this is also okay. You can go through this path. See, you have 3 paths here. Tejana, my darling. Guys, just today I know you guys have exams next week. You cannot give that much prior to term test. but this is tanka kiyada තියෙන්නේ දෙකයි තව දෙකයි ඔය දෙකේදී මගේ ස්ටුඩන්ට්ස් definitely results දානවා ඒකට එන්න ඕනේ OMG okay can I move on page okay this one if you directly go with bromine Mathotaarachchi director, but deactivate, you can change one single to join 3 bromine. Either you're supposed to go with OH or NH2 and leave no phenol. But phenol is taking phenol, OH minus is not that easy because reactions with phenol is okay, but then converting it to bromine is not easy. So we're going to go with through this aniline and diazonium, NO2. NH2 and then now when you add bromine water you are joining this Mathotaarachchi or this tribromoaniline sodium nitrate HCl convert NH2 to N2Cl that N2Cl with CuPr HBr somewhere you are converting to bromine හරිනේ දැන් ඔයගොල්ලෝ S2 පියාගෙන කරන ගානට organic ඇවිල්ලාද දැන් තේරෙනවද මම දුක් විඳලා වෙදලා මම දන්නවා you guys I was torturing you guys දැන් ඔයගලන් organic වලින් ගොඩ නේද organic වලින් දැන් ගොඩ so equilibrium already good so මේ සැරේ මට marks ඕනේ ඕනිමයි මේ සැරේ අර කලින් වගේ ආනේ term test okay ලකුණට වලට කමන්නේ නැහැ කියලා දැන් නම් කියන්නේ but there's a one single issue with zonal papers this is the I don't know maybe good tradition okay they say ළමයි ප්‍රශ්නාංක 27 පොඩි issue එකක් තියෙනවා හදාගන්න because you guys done already ප්‍රශ්නාංක 27 then you guys are doing the whatever the editing and yeah redoing the question ළමයි අර ප්‍රශ්නාංක 27 තව චුටි ප්‍රශ්නයක් තියෙනවා හදාගන්න seriously that happens so is this your very first honor no I guess yeah now you තිබුණාද කලින් school papers but same time ah that's okay Karin sir that's okay school papers are okay is this a place මෙතනද මේ මම දැන් අර සිංහල ඉංග්‍රීසි අවුල යන හින්දා මට let me get this okay check your answer this kind of a structure I feel this structure is a little weird so I drew my own structure see very easily you guys can see this 4 chloro 3 ethyl 2 nitropent 4 enolic acid जो खाली पार्ट का मिस बना रहा है okay when this acetophenol reacts the mixture of nitric sulfuric, you are getting 3 nitro derivative. 3 nitro mean meta, they want us to explain this through the mechanism. Okay, usually what I do is I go with explanation with words and diagrams together. I get that practice. In case if you miss the point here, you can get that here. Considering the mechanism, they want us to explain this anyway. Electron density of benzene ring is high, so the favoration goes for SE reaction favors electrophilic substitution. Don't write this. you have to write electrophilic substitution because they are not giving marks for your science. Once the group attached already, that group decides or controls the position of the second electrophile attached. Don't write E plus, just say electrophile. Here electrophile is NO2 plus. COCH3 is ring deactivating meta-director since it decreases electron density of both para positions. This clearly shows NO2 plus goes to meta position since its electron density is comparatively high. Here now I'm not going to stop there, so I'm going to show it with these resonance structures. Okay, you're going to show these as well. I'll read this again if you want my explanation, otherwise you can just copy this down. Electron density of benzene ring is high. Electron density of benzene ring is high. Therefore favors electrophilic substitution reactions. Therefore favors electrophilic substitution reactions. Don't write short forms. Once a group attached already, that group decides the position of second electrophile attached. That group decides the position of second electrophile attached. Here, electrophile is NO2 plus. Grammar godak balanna, they are not checking grammar for the final exam. They are only giving marks for keywords, so make sure not wasting time. CONH2 group is ring deactivating meta-director. COCH2 group is ring deactivating meta-director. Since it decreases electron density of orthopada positions. Since it decreases electron density of orthopada positions. NO2 plus goes to meta position. NO2 plus goes to meta position since its electron density is comparatively high. Its mean meta position electron density, okay? Since, you can just write since electron density of meta position is comparatively high. Electron density of meta position is comparatively high. And it is a must. It is a must that you are drawing resonance structures to show. See, these positions are getting plus charges. These positions are getting plus charges. So that only it is directing to meta positions. Okay. This one, OH, COH and OH, meta to each other. They want us to join one COOH here. You can do it very easily with Friedel-Crafts alkylation. Convert it to COOH. And then that's meta. So that you are joining NO2 to meta, convert to NH2 and then to OH. Or otherwise, NO2 and then at that time CH3 and then convert NO2 to NH2, NH2 to OH, and then this CH3 group to COOH. That is again another method. I have not written reagents there. This method is also possible. This is my main method was this one. NO2, just leave it, CH3, CH2 to COOH, and then this NO2 to NH2 and OH. Couple of methods are there. All are correct. If the compound they were given like this, just draw this expandable structure. Two CH2 groups are like here you have joined like two identical CH3 groups. That comes with this green rod with carbonyl. Okay, I can make very easily green rod from this Cl, MgCl. To that, when you add this CH3CO, CH3, that part is this. Just OH2 PCl3Cl, CC. If you are getting same mechanism continuously, just don't waste time on that. See the next question number 48 again. So the mechanism. We did this couple of times, electrophilic addition. I'm just moving on. Okay, ICl. What happened to ICl? If you join ICl here, iodine delta plus chlorine delta minus. So iodine is supposed to join first. Here. Just consider this is as HCl, then this is hydrogen. Hydrogen positive, hydrogen is high. You are getting more stable secondary carbocation, so that the more electronegative one is joining there. With the inductive effect, this one is more stable. They are only asking this. But if they ask the mechanism, this is supposed to be the mechanism. සිංහල මීඩියම් ටික පරද්දලා මේ සැරේ මට ලකුණු දාන්න ඕනේ. හරිද? හරියට වැඩ කරා නම් ඔයාලට ලකුණු ඔට්ටෝ වෙනවා. It is not like that you guys have to put much effort for this term just to get marks. But if you guys are in the path that I'm expecting, that I guided you, you definitely would get marks. Okay, next one, C4H11N with primary amine, and that's a primary amine, so NH2 group supposed to be there. Primary amine NH2, so long chain, and I'm gonna detach this carbon and joins here and joins here, and then I'm gonna detach this carbon and joins here, and that is this. Only these are the possibilities. Usually they are not expecting you to draw these two, but I guess now you better to draw them. For your exam, මේ දෙකත් අඳලා තියන්න. L එකයි D එකයි මිර එකක් දාලා දෙපැත්තට අඳලා තියන්න. මෙහෙම ඉතුරු කරන්න එපා. මෙහෙම ඉතුරු කරන්න එපා. Part 2. If B shows optical activity and have enantiomers, draw the structure of the hydrochloride of B. Okay. මේකනේ මේක මේ පෙන්නලා තියෙන D නේ C නේ ඒකට එක hydrochloride is this. Is that clear? Could you get the answer? Tejana, this is easy for you. Questions? Good. I was so worried about a couple of you in the path, but I feel really comfortable now. I have this big belief that you all are working really well now. කලින් කරාන එකක් ආයෙ මොකක්ද මේ NH2 ගන්න මේ තුන දාන්න then you can remove NH2 N2Cl H2PO2 then you are just removing that එහෙම නැත්නම් මේ වගේ සමහරක් අය ගිහිල්ලා දෙන ටක් ගාලා once you guys are panicking at the exam then brain plays you know the tricks on you then අර මේ easy method එක අතහැරලා යනවා so මොකක් හරි තියෙනවනේ talent එකගේ තියෙනවනේ then you can find some other methods as well. BR2, FeBr3, you can join like meta. Then just keep it as it is. Then you are going with NO2, NH2, N2Cl. And then you can remove that with CuBr, CuBr, HBr, another Br, sandman. That is also possible. How is other two subjects? Really comfortable. What am I doing? I have my applic sister and all this. Brand kari have recruit kara. Then to kira ne applic class na ne. Baki na me sesuka ke. Ekini sa si hatar ko na kare tani ne ogulan syllabus ka kari berkan na mo kati na tienwa. එහෙම එකක් මම හිතන්නේ මේ මංජුලත් එක්ක කියලා තියෙනවා. අපිත් එක්ක කිව්වේ නැත්තම්. එහෙම වුණොත් it's okay අරන් වෙනකන් මතක තියාගන්න. කොහොමද මම මේ ක්ලාස් එක දානගෙන හිතන්නේ ඔයගලන්ට එයාගේ පොඩි ක්ලාස් එකක් කරලා. Okay. This one bromo, 2 methyl, 5 nitropent, 3 in, 2 all. This is the main chain. Possible structures for mono-substituted, so you can go with di-substituted. Once you remove this benzene ring, C2H3O, C2H3O. Then I'm just going to draw 2 carbon and then oxygen. Then if you put all other hydrogen, 2 hydrogen here, 1 hydrogen here, so it's unsaturated. So anyway, I'm going to start from double one here first and then change it to the middle and then this unsaturated, this compound. Unsaturated this one and then going to this alcohols, so you can go with cis and trans and also changing the OH position here. And also this cyclic structure also possible. Because they don't give any restrictions, then you have to go with all possibilities. Just let me know if you guys need any, like, you know, the even equilibrium recording or something like before term test. If you want to get more practice, just ask me, okay? 11 or 13. Are you guys done the syllabus? How much you guys done at school? කොහෙද ඉන්නේ? ඕකනේද? දු? මතක නැහැ. What do you mean? ඔයාලට මේසරේ දාන්න බැන්න වැඩක් නැහැ ඉතින්. මේක. Okay, starting material is benzene, CH2OH and NH2. මේවා නම් චුට්ටක් හිතලා පාර්ට්ස් ඔයගොල්ලෝ ඔළුවසේ හදා ගන්න ඕනේ. ඉතින් අර CH2OH අපි කලින් ගත්තානේ. නේද? So meta, ඒක නිසා I'm going to join the meta one first. I'm just going to leave it. And then chlorine or bromine, then renard to that formaldehyde, CH2OH. Just leave it as it is, and then this continuous NO2 you are converting to NH2. Or otherwise there is another method, CH3, COOH. This is meta, then leave it as it is. Then you are joining NO2 and then NH2 and then this COOH to CH2OH reduction lithium aluminum ether. Or once you get here lithium aluminum hydride ether to convert this to CH2OH and then this NO2 to NH2. You can solve these two steps. Last two steps you can solve. Always make sure when you are doing a conversion, are there any interventions if you are doing another method? Is my method correct? Like when you change your steps, if something is changing, then you have to consider that better. Like okay. Only one single rule is you're going to start from benzene to get this one. Couple of methods are there. Okay, so one side is supposed to be Grignard, so bromine, MgBr, that is the first path. I'm going to go with blue the second path, and then NO2, NH2, N2Cl, Cn, COOH, COCl. Then you will add these two together. They just say that one single organic keyword you cannot use this one. They were not saying that. So that even if you go like this, this is correct. Once you made this, no, you can make it. Here you can make it. Sorry, you can make it. Okay, when you decrease the temperature, you are making this phenol, and then you are adding these two together, this phenol and these two together. That again comes to make this ester. Through the ester, if you add this same Grignard here, you are coming to the same product. See, different methods are there. Sodium nitrate HCl, temperature greater than 5. You can write room temperature. Yeah, we are here. IUPAC naming, that's again I feel like little like not comfortable, so I made it like this. This is the main chain. 4 bromo, 2 chloro, 3 ethyl but, 3 enal. This one when benzoic acid is reacted with mixture of conc nitric and conc sulfuric, 3-nitrobenzoic. Earlier we did. Again they are asking. See, refer question number 14B. Never make a 14B. The numbers are different. 47. Refer question number 47. Okay, 47. Electron density of benzene ring is high. Only difference is now we are exploring this COH group. Electron density of benzene ring is high, therefore favors electrophilic substitution reactions. Once COOH group attached, it controls the position of the second electrophile attached, and the second electrophile is NO2 plus. the one already joined. COOH is a mild ring deactivator, meta-detector. Since it decreases the electron density of meta position, since it decreases the electron density of orthopara position, the next group is joined into meta position. Exactly same thing, but the given group is different. Exactly same thing. Electron density of benzene ring is high, therefore favors electrophilic substitution reactions. Once COH group attached, it controls the position of second electrophile attached. Electrophile is NO2 plus. COH is a mild ring deactivator, meta-detector. Since it decreases the electron density of both para positions, next group is directing to meta position. Then we are showing these resonance structures. Okay, I am showing both here. Just normal conversions. Both are meta, so we're going to start with one of the meta one because these two are orthopara, but their connection is meta. So NO2. Now it is meta, so now we're going to join bromine here, leave the bromine as it is, NO2 to NH2, N2Cl and Cl. Bromine now just stays as it is. And then this one, what would you think about this carbon? Two of these groups are joining. Two of these groups are joining COOH. Before this, they are supposed to be like one hydrogen here, CH3, either Br or OH, some sort of thing supposed to be here to make this double one. So that definitely supposed to come to the cyanohydrine. Cyanohydrine are making between carbonate and HCl, HCN. So I'm going to make this one part is CN. CN becomes COH. Then I have to join two carbon here and one carbon here. So I'm just first joining this CH3 group here, one carbon CH3 group. Yeah, para is more possible, but still ortho is okay. So I'm gonna just keep this ortho because they are just giving it to the ortho. So to the ortho position I can join this. Now rest of everything is easier. Adding CN here, at the same time OH here, and then CN to COOH, CN to COOH, and then concentration 472 make the double. This one, this is okay actually, but I have drawn this one to make it more clear to you. 3-hydroxy, 2,4-dimethylpent, 4-enoic acid. 3-hydroxy, 2,4-dimethylpent, 4-enoic acid. Thing maker. Last couple of questions we did that. Then again conversions. See, makeup we did this at the class. Only difference is, only challenge in this question is, these two are meta positions to each other, but both these are orthopara directors. So that we have to first join a meta director because the connection is meta here. So we have to go with to join R groups, not the alkylation but the acylation. So joining that to get this 3 carbon. Okay, just leave it as it is, and when you are adding another any group that is directing to meta position, and then Clemmensen reduction to remove this CH2. It's easy. It's easy. If you done normal theory, these questions are like nothing. Okay. This is meta, and then chlorine is orthopara. Connection is orthopara. So first I'm gonna join orthopara one, which is the chlorine. කැමතිනේ ඔයගොල්ලෝ මේ chlorine පහලින් පෙන්නන්නත් පුළුවන්, but I have taken here and leaving it as it is. Now I'm going to make this CN. For that, NO2, NH2, diazonium, and then CN. Upside down, only the flipping of the upside down, and nothing is changing otherwise. This same CL, just maintaining. මට ඔයගලගේ මනස විශ්වාස කරන්න. මම ඉතින් ඔයගලන් හැමෝම ගැන ගොඩාක් හොඳ කිව්වා. Seriously, you guys are doing really good නේ. She is really happy. ඉස්ට ගොඩක් කෝල් එකක් එහෙම තියලා කතා කරන්න හොඳ අතීතයේ උගලන්ට ගොඩක් ආදරය කරපු ගුරුවරු. මොනවා ගැන හරි අගරහන් ෆීලිං එක කතා කරන්න දැන්. දැන් ඔයාලා ගිහිල්ලානේ. Nomenclature like this. 4 ethyl, 3 iodopent, 4 in, 2 on. Have you another? You can do silly mistakes now. Don't get used to silly mistakes. Anything wanna make I කියනවා. ඔයගොල්ලන්ට guessings දෙනවා නේද teachersලා? මේ papers කරලා නැති ළමයින්ට ටීචර් කෙනෙක් ගෙසින් එකක් දුන්නා මේක මාන ලොකුයිනේ. දැන් ඔයාලට වුණද ටීචර්ස් වගේ ගෙසින්ස්. ඔයගලන් ෆුල් papers ගන්න පටන් ගන්නදී මම ඔබ කියනවා පොඩක් බිත්තියේ පේන තරමේ කොළ තුනක් තියාගෙන තමන් කරන සබ්ජෙක්ට්ස් තුනේ ගෙසින්ස් ටික ඒවා ලියන්න. පේපර් එකක් කරලා papers 3-4-5ක් යද්දි දැන් උගලන්ට හිතෙනවා ඊළඟට මෙන්න මේ වගේ questions තමයි තියෙන්නේ කියලා. එහෙම ලියාගෙන යද්දි ඔයගලන්ගේ paper එකේ එන ගෙසින්ස් ඔළුවට ලැබෙලා ඉවරයි. Maintaining a style. එහෙම තමයි ගෙසින්ස් හදාගන්නේ. සෝ මට මගේ මොලේ වෙහසන්න ඕනේ නැහැ. උලෝගල මොලේ වෙහසලා ගෙසින්ස් හදාගන්න ඕනේ. Okay. Conversions. ආයත් cyanohydrin කතාවක් නේද? එතකොට මේකේ other than this COOH group, this has only 2 carbon. So I'm going to go with 2 carbon, carbonyl. And then HCN here, COOH. So අර කලින් කරපු question එකේ part එකක් අගෙන මේ C11 ඕන. How will see? Is this green color disturbing? No? My name? අර black and white වලට වැඩි වෙනසක් ඕනේ කියලා හිතුණා because I was only using the grey color. Anyway, this one you can write this way. This is the molecule. The කොට 3 carbon එකක් මෙතනයි. 3 carbon එකක් මෙතනයි. So they say they were given only this. මේ ඇතිනේ. නේද? ඔය දෙක yeah, either aldol or either you can try. Can you try green on? Did you guys try green on here? Is it possible? I didn't try green on here. Anyway, so CH3CO CH3, then go through aldol. No, you not green on because 1 carbon is down here. Okay, so this is aldol. This is aldol, and then heating and removal of this with Clemens reduction. The green on method, yeah, green on method is okay, but it's longer. If you want, you can try. Then make alkyl peroxide. Once you're adding alkyl peroxide, you can get this terminal bromine, green on, and then to that, you can add this one, maker. Green ordering in a makai, when a makai with color, you guys can get here. I will get one of you to it once you've done the exam. I'm waiting so excited to get you to my crew, couple of you. And I want one of your because my English handwriting is so like Okay, make a, okay, this is the main chain. This is the main chain. 5 bromo, 2 nitro, 3 propylpent, 3 enoic acid. And then distinguish this with each other. What are differences? You cannot do anything with this OH. Both are having tertiary OH groups. But then you can do something with this NH2 here and NH2 here. This is primary and this is tertiary. May side again tertiary Na and this side is primary. Paths I have shown both ways. Concentrations and heating. Concentrations and heating. Then you are getting a double one here and here. And then sodium nitride HCl. Sodium nitride HCl. Then convert NH2 to OH. This NH2 to OH. Then Lucas. Zinc chloride concentrated to both sides. Then OH is now converting to Cl. OH is to Cl. Then the primary tertiary. So the instant turbidity after 24 hours. Okay, to A and B at H2SO4 170 separately. I am making. This is also not bad. Okay. To A and B at H2SO4 170 separately. Followed by sodium nitride HCl. Followed by zinc chloride HCl Lucas. A shows instant turbidity. B shows turbidity after 24 hours. B shows turbidity after 24 hours. And then the next one is both are esters. CH3, CH2O, CH3 twice CHO. Anitike, once you break them, making enwa mename part and make primary alcohol. Making me primary main part and then secondary alcohol. So if you oxidize, this becomes CH3, CH2COH, CH3COOH. But here this is giving CH3CO, CH3, the secondary alcohol, and then react with the 2,4-DNP, ready. So no reaction here, but this side orange precipitation. So that you will write to both X and Y, add sodium hydroxide to hydrolyze, followed by acidic KMnO4, followed by 2,4-DNP. Y gives orange precipitate, X no change. You have to write both sides. X no change. Make up method ganna spaces fill කරන්නනේ. Free to craft acylation. For the reaction, suitable catalyst is anhydrous aluminum chloride. To attack benzene ring reaction is electrophilic substitution. So this is the because this is stable, you can show this separately. This is stable. This attack is called, you have to write exact name, electrophilic substitution. Do not write this. Because they are not giving marks for us for that. Again. When you do this second time and third time, you're going to be really, really comfortable. Make it better. Okay, this is clear, I guess. Okay, 3-bromine, you can go with phenol or aniline. So aniline given, so you can get 3-bromine very easily. And then NH2 to disonium N2Cl, CN, CH2NH2. How easy. This again, this is the main chain. So the name is 4-bromo, 3-propyl pent, 4-ene, 1-off. Make it thin on the fill spaces. Here. A brief description pertaining to the reaction between aqueous casein and bromoalkane. They were given this one. This is a tertiary alkyl halide. So the reaction type is SN1. So it makes this stable tertiary carbocation. Cn minus attacks onto this. So this is the mechanism. This reaction is called a nucleophilic substitution reaction. And this is the mechanism. And this is the mechanism. Tertiary, so this tertiary carbocation can exist itself all by itself at the medium. Okay, so the next part, they are going with this carbon joining here. So that pre-craft alkylation is supposed to start from this carbon. So if we add RCl, Cl gets away joining R, mean whatever this chlorine joins, that carbon is supposed to be the carbon joining with benzene. So that this part becomes this part here. One step. Can I have a Sinhala go May 2000 name we had a name. Is a organic monoid than be a bigger way, but I than had organic major iconic neoplank body hit them. Okay, pentan 2 on. So this is pentan 2 on. They were given that. They just want to complete all this. What are the steps? The very first step is we have to make this 3-carbon aldehyde to 3-carbon alkyl halide. That's very easy. Just before this, we have oxygen here, so that before this there are supposed to be this OH. To get here you are adding lithium aluminum hydride, ether and water. CO becomes CH2OH. Then CH2Br with PBr3. That's easy. Then to this 3-carbon compound. 3-carbon compound, they were adding another 2-carbon compound. Yeah, you can go with green art, but steps are higher. So the easiest way is, this is the alkyl halide, chain extension with sodium acetylide. Chain extension with sodium acetylide. This is this part, and this is the 3 carbon part. Then alkyne hydration. Alkyne hydration. That easy. So now we are coming to this little challenging organic chemistry again. Compound PQ and R. Compound PQ and R all have the same molecular formula, C7H14. That is an alkene, okay? Alkene. Exhibits optical isomerism, so they are supposed to be chiral carbon. None of them is a geometrical. So the double bond method gonna just no cis trans, okay, no cis trans. Or optical isomers of each other. So you can draw 2 optical isomers together. Undergoes catalytic hydrogenation to yield same compound S. So this is the starting point. This is the starting point. Same compound S mean they are supposed to have same skeletal structure. Same skeletal structure. C7H16 and exhibits optical isomerism. Okay, so that if you go with the normal structure, the final structure is, I'm going to go with S first. Okay, so I'm just drawing here 1 hydrogen, 1 carbon, 2 carbon and 3 carbon. Or otherwise I can go like this. I can detach this carbon, let's say this blue carbon. I can join the blue carbon here. But then the problem is we need 3 alkenes here. But if you go with this one, මේ carbon exactly same. So if you put the double bond here or double bond here, it is same. So I cannot go like that. So I'm going to go with the first structure. So I can make 3 double bonds at these 3 positions. 3 double bonds at these 3 positions. See colors another. Okay, double bond here is the structure, and then double bond here is green with the structure, and then double bond double bond එක මෙතන මේක double bond එක මෙතන මේක, or otherwise down here is this one, and this is the S that we draw all the time here. This is this S. Clear? ගත්තද? තේජනාවද? You didn't try. Okay. It's easy, but you guys have to try. And then they say geometric isomerism. One of these is showing the geometric isomerism, and that actually is Q. See, you have double bond here, geometric isomerism, and here again exactly the same way I'm showing its optical isomerism as well. Then stop this side, H and CH3, CH3 and H. Easy, very easy. Chanindi, did you do this? Easy. Yeah. Can I move on? So you're going to write this later. Did? No? Okay, this is easy. Carbon. We're just going to draw one hydrogen, one carbon, two carbon, three carbon. I just went like this because I want this chain to be the longest chain, or otherwise you can detach this carbon and join it here. This carbon is this. Both are possible. Just don't draw one. All the possibilities you can go with. Then count numbers and you can write N7, M16. N7, M16. Okay, this one again. Now we see. 111 CO. Rather this catalytic hydrogenation, okay? Clemmensen reduction. Actually, if you done this really good at the final exam, you wouldn't find one single challenge. Okay, 3 carbon, same 3 carbon, so that this CH2OH, you have to convert to CN. To get CN like that, we have to go through this CONH2, P2O5. Then make this amide, carboxylic acid ammonia or acid halide ammonia. This sounds like a little complicated, but if you go little by little, this is easy. Anyway, after first chapter, only from here to here. Initial one they were given 3 carbon, and again you have here 3 carbon and then 3 carbon. Okay, not direct joining. Directly make up joining and may matter CH2 group so they're supposed to come through aldo. We can give it a try. Usually may 5 carbon may chain acetone or aldol කියලා memorize කරගන්න. So going through the aldol, but they were not given a separate step for you guys to write this first, like this alcoholic part here. So they were not given space there. So you have to go with sodium hydroxide and heating together to get here. And then there are no any other groups here. Only one single OH. Then to remove the double bond, you are just going through this nickel hydrogen. Just remove that part. And then may second carbon to this second carbon you have this OH here. Then lithium aluminum hydride ether and water. Okay, again the difference between this one and this one. This part is this part. To that, again they were adding another acetone part. See, directly to this carbon, directly you're going to add this carbon. to this carbon and this carbon directly like this. Then you can come through the Grignard. And they say, to confirm that, they say this is magnesium ether, so that I'm going to convert this bromine OH to bromine and then MgBr to react with that. Anyway, you need you need a carbonyl, and the carbonyl is given, and then acidifying acidic H2SO4 and heating to remove this OH to get the double bond here. Could you think like that? If you think like that, it's really, really good. It simply means that chemistry. අර බඩින් කියන වර්ඩ් එකට නේද අර පොඩි දවස්වල රිෆෝමේෂන් එකේ ලිපුව අවුලක් වෙලා තිබුණේ නේද? හරි වගේ එකක් නේ. වක්‍රයි වර්ඩ් එකකට how many years ago I did my this very first undergrad. So we had this couple of visiting lectures always coming, like different like people who had talents, they bring to give us lectures. Then professor he was like, do you know the meaning of budding chemistry? What's the meaning of budding chemistry? So that's the best buddy for you. Like you're so supposed to feel that you know chemistry. You're supposed to feel you are very comfortable with chemistry. So that is budding chemistry. And you guys are like budding organic chemistry. Because organic chemistry is now like you supposed to feel whatever the question they are giving, whatever the way they are tailoring the questions, we can do this. So if you have that feeling, you guys are free from all the frustrations of organic chemistry. Okay, so the next one, 57. Makeup. මේ මම green color steps දාලා තියෙන්නේ, those are the steps that the way I have thought. මේ මේක number 1 අරගෙන තියෙනවා PBr3. PBr3 දාන්නේ කාටද අපි? We are adding PBr3 to OH, and then after adding PBr3 there is this double bond here. How do you make the double bond? By removal of HBr with alcoholic KOH. So that after you adding PBr3, hydrogen goes to where hydrogen is high, and then the other carbon gets this bromine. So this carbon is supposed to get bromine. So that I'm joining bromine here. Understood? And then before this bromine, PBr3 adding to OH. So this is OH. How easy the life is then. And then sorry guys, it's okay. I'm explaining this second one, okay? I'll go back to the first one. I was feeling like this whole thing is one single convention. So they are adding anhydrous aluminum chloride to something. At the end of the day, you have this benzene here, plus you have this OH group as well here. OH check group. So you are not coming through the alkylation, you are coming through the acylation, but that's supposed to also have this 3 carbon. So that I'm starting from 3 carbon, this acylation to benzene, because initially they were given benzene here. And then I'm adding separately these 2 carbon through the Grignard. If you go back to the first one, make and it started from here, this one, so that you're gonna reduce this one and then dehydration. And also adding bromine to something, and this part H2SO4 and mercuric sulfate. So they are supposed to be a triple bond to give this one. To get the triple bond, you're going to start from a double bond and add 2 bromine to get bromine, then alcoholic OH. How easy, how easy. Okay, this little conversion. May this part comes with, I feel like through these questions they are teaching you guys a syllabus in another version. It's like another version of syllabus. Get this full knowledge. Okay, Jiviti, after 10 more years, you're supposed to stay in very comfortable life. Maximum. So what is this? This is an imine. How would you make imine? Imines are coming through carbonate compounds and amine compounds. This part. So you are making these two. So make a make a COOH, COCl, CONH2, CH2NH2, and that is this part. And then the other side, make it directly දීලා but you can make it. See, I'm showing the path to make it. Lithium aluminum hydride, ether, water, then PCC. They shouldn't have given that. Okay. Make a time duty. Simple, they are neither. This is meta with each other, but both are utpara. So meta ekak wenna then thine. Cradlecraft acylation, and meta director. Then you are adding bromine, and then lemons to remove this CO to CH2. I cannot mosquito is here. How easy. Janandi, are you feeling your don't get stressed. Are you feeling your tune nicely? Exam your Africa. Because this one is very, very ugly. Okay. Okay, moving to this question. So I'm going to go with this. I'm going to make a clear one. Compound X, C5H10O5 on reaction with PCl5 gives the compound Y having relative molar mass 205.5. Reaction of 1 mole of X with sodium carbonate. Who's reacting with sodium carbonate? It's supposed to be carboxylic acid because you have 5 oxygen. Let's see. Carboxylic acid particle sodium carbonate gives CO2. Oh, one more. See, to get 1 mole of carbon dioxide, there are supposed to be 2 moles of carboxylic acid. You have to write the equation, okay, to get this. So that I have written here, since you are using 2 here, I have written here there are supposed to be 2 COH groups. And then they are asking alcoholic hydroxyl groups. How many alcoholic hydroxyls are there? Okay. So once it reacting with PCl5, so the molar mass is 205.5. But without that, molar mass is 150. 205 minus that equals 55.5. Okay, so this OH gets away chlorine joins of carboxylic acid. OH gets away chlorine joins, even its alcohols, so that one chlorine is replaced with one OH. So the difference supposed to be one chlorine and one OH. Between one chlorine and one OH, difference is 18.5. But here the difference is 55.5. Then how many OH groups? 55.5 divided 8.5 is 3. But then, since it is reacting with 2 COOH to give 1 CO2, only hydroxyl OH is supposed to be 3 minus 2 is 1. Only one single hydroxyl group is in the X. Let me know when you guys need the break. It's your call today. Okay. Start from benzene. See. Okay. Make a benzene විතරයිනේ දීලා තියෙන්නේ. If you break these molecule, see මේ බලන්න බය වෙන්න එපා. Once you see these bigger diagrams, don't get scared or panicking. Panicking තමයි final exam එකේදී අපිට සිතෙන්න පුළුවන් නරකම දේ. අපිට වෙන්න පුළුවන් නරකම දේ තමයි අපි panic වුණාම it covers the talents of our brain. Panic නොවි යන්න මේ අපි මේකනේ මේ ගොඩාක් patients කරන්නේ to stay away from this panicking. මොන බලන්න බෙන්සීන් එකක් තියෙනවා මෙතනට එක group එකක් මේ මෙටා වෙන්න ආයෙත් ඒ වගේම මේ මෙටා වෙන්න group එකක්. So මොකක් හරි common තරමින් අපිට start කරලා යන්න පුළුවන් කියලා it's very obvious. And then you guys see this ester part here. So we're going to make this alcohol and then this carboxylic acid separately. අපි බලමු ආඩට එළියෙන් ඇඳලා මේකට එන්නත් පුළුවන් නැත්නම් පෙන්සිල් එකකින් කරලා මකා ගන්නත් පුළුවන්. Okay, this side has 1, 2, 3, 4, and then the other side is having 1, 2, and 3. And they say addition of L and M gives this final ester. So then you're supposed to write this, whatever these two compounds here. So if you go through this one, you would understand that you have an extra step to make alcohol. So I'm going to get this alcohol side here and then acid side the other side. Anyway, so the first one is, because for the both, we need to join this bromine to meta position. So I'm starting from Friedel-Crafts acylation. And then to both, I'm adding bromine. And then this one, see. Once I come here, so this is enough for the acid side, but that's not enough for the base side, and to convert this COOH to CH2OH. So that I need an extra point to this side, and then add these two together to get there. These two parts are also okay. These two parts are also okay. CH3, COOH, then Br2. CH3, COOH, Br2. Same. Can come through that part as well. Okay, so the next part. This is a hydrocarbon. They have not mentioned other than that anything else, whether it's saturated or not. So I'm going to start from the fully saturated alkane, and then it's CnH2n plus 2. Then 12n plus 2n plus 2 is 58. 14n plus 2. So the 58 minus 2, 56 divided by 14 is 4. 4 carbon, 10 hydrogen, then you are going back to 58 is the molecular formula. And they are asking the structures, only these two are existing. You cannot make 2 pi bonds to this one. Okay, they say this one, 1 mole of this, whatever the A, is reacting with 2 moles of H2, so that it's supposed to join 4 hydrogen. 2 H2 mean 4 hydrogen, so that they are supposed to be 2 pi bonding. So you cannot give 2 pi bonding to this one. So answers can be here, either one single here, a triple bond, or otherwise double bonds separately, 2 double bonds separately. You can draw only 4. They ask us to draw 4. Anyway, only 4 are there. CuC2 terminal. So this is the answer. Terminal. Okay. So now we are concentrating onto this B here. They say isomer of B is C. Goes through the alkyne hydration, gets D, and with the gray D, it is giving this orange color. So this is B, then this is supposed to be C. This actually is C then. This is C. And this is alkyne hydration, and this is the gray. See, they are asking that. You're supposed to have the memory of 2,4-D and B. This is 2,4-D and B part. Honey, could you be able to complete all the MCQs, everything? How many remaining? 50. Top page එක දිය තියා ගන්න ඔයගලන්ට MCQ කරන්න තියෙනවා මෙච්චරක් කියලා. Sometimes when you get time you can do that. අපි next week යන්නේ මොනවටද? 11 නේ. බලමු මේක ඉවර වෙද කියලා හිතුවා. Let's see. Okay, just the product. Nucleophilic addition, so OH and CN are joining, and then nucleophilic substitution, this OH instead of Br is joining, and then this one, electrophilic addition, double bond adds to bromine. Nitric sulfuric, electrophilic substitution again, electrophilic substitution. So you are adding this NO2. And then check this table. Electrophilic addition, Br plus, electrophilic substitution NO2 plus. nucleophilic addition CN minus, nucleophilic substitution OH minus. Next one then, or let's just, we can do up to 11 if you guys are not hungry. Depend on you, just ask me, okay? Whenever you feel hungry, ask me. Okay, this one. Intermediate structure. These are easy. If you do this, very easy. With hot acidic KMnO4 benzoic acid. What a benzene ring could make it, you know. It has a benzene ring. On a benzene ring, you can reduce that pass say what it you know C3H7O. Reacting with sodium colorless odorless gas nirgandha. Nirgandha කියලා වචනයක් අහලා තියෙනවද? Odorless. So it's supposed to be either alcohol or phenol, and with conc hydrochloric acid and zinc chloride cloudy, immediate cloudiness, immediate tertiary alcohol. ඔන්න අපිට point එක ආවා tertiary alcohol. So benzene එක දාලා carbon එකක් දාලා දෙපැත්තට CC දෙකක් දාන්න. ඔන්න benzene දාලා. So only remaining become OH. Then it's become very easy then, tertiary alcoholic part. Okay, then this is the answer. And then the gas is H2. Gas is H2. Why? KCN nucleophilic answer sticker. I'm just gonna write answers here because you can fill the table easily then later. CN joins here, I didn't get survey. CN joins. So nucleophilic substitution, nucleophile is CN minus. And then the next one, HBr, electrophilic addition, H plus is the electrophile. This bromine joins to the middle carbonyl, stable carbocation. This is aldol product, nucleophilic addition, and then CH2, CH3 with a negative charge. Carbon anion is the nucleophile. This one, mechanism, any other mechanism, MO. මේකේ අපි මේකේ මෙකැනිසම් එකක් ගැන මෙතන දීලා නැහැ. අපි කතා කරලා නැහැ ඇඩිෂන් එකක් තමයි. but එහෙම කතා කරලා නැහැ. hydrogen එක here, that's NO. And then this one, nitration. Electrophilic substitution, electrophile is NO2 plus. And then you can fill the table like this. And then part 5, nitration reaction, they want us to, any of these are accepting. They are asking this intermediate. Any of these are accepting. ඊළඟ බලන්න. A and B are, question number 61, isomeric hydrocarbons each have 2 sp hybridized, mean they are supposed to be මේ double one triple one part එකක් තියෙනවා. triple one part එකක් තියෙනවානේ. and to sp3. so sp3 තියෙන නම් single bonds තියෙන දෙන්නෙක් ඉන්නත් ඕනේ. single bond තියෙන දෙන්නෙක් ඉන්නත් ඕනේ. මේගොල්ලන් ඉන්නත් ඕනේ. either this way or this way. possibilities, okay? Substitution of one of the hydrogen atom in B by a chlorine atom gives C. C shows optical isomerism. To have optical isomerism, if this comes to the middle, make a method of CH2. Now, optical isomerism gonna bad name method out. A chiral carbon A and B compound A and B separately react with a mixture of water, mineral acid and catalyst. See, water, mineral acid, catalyst, that only they are saying that actually is the alkyne hydration to give compound D. D has 3 sp3 hybridized carbon atoms, 1 sp2 hybridized carbon atom and 1 oxygen atom. So ඒක නම් දෙකෙන් ඕන එකකින් එන්න පුළුවන්නේ මේ part එක මේකෙන් ගන්න දෙයක් නැහැ. So if you go with adding of HCl, if you substitute any chlorine from this, see, any chlorine to this one, still you have 2 hydrogen. But if you substitute any chlorine to this one, you have only 1 hydrogen. That is the one which is showing this chiral carbon here. So Y is Hg2 plus. Distinguish between terminal and normal alkyne. Ammonical nitrate or toluene gives white precipitate, and this is the product. Cuprous chloride, ammonical cuprous chloride with B gives red-brown precipitate, and that is this. A doesn't show. You have to write that as well. A doesn't show that. You guys have your English medium questions with you. Major organic products, mechanism, electrophile, nucleophile and color they are asking. If you go one by one. This iodine replaces with this OH, nucleophilic substitution, nucleophile is OH minus. Color no difference. Double bond breaks, H and OH joins, Markovnikov rule, electrophilic addition, H3O plus is the electrophile and that's again colorless. There is no color. Next one, alcoholic KOH, that's elimination. That's elimination and that's colorless. This is electrophilic substitution. Electrophile is C or CH3, colorless. And I have Tute when Sakala method CHO is already there. Oh yeah, that is Brady. Brady. This oxygen and this nitrogen gets away. With respect to this benzaldehyde, this is nucleophilic addition. 2,4-DNP is a nucleophile. 2,4-DNP is the nucleophile. Color is orange. With respect to C, may part just let it be there. Who cares? With respect to phenol, this is a phenol, its electrophilic substitution. Who is the electrophile? The diazonium, and that's again orange. Okay, question number 62. Make a color break again. Are you want to break now? Or gonna get a break after this? Kiana? Janet, are you hungry? Teja? Okay. Or hungry? A, B, and C are three isomeric hydrocarbons, each having two sp3. So if it is sp3, there are supposed to be a carbon joining with another 3 sigma bonding. Okay, two of them, and then the other one is sp2. sp2 mean the double one. sp2 mean the double one. A shows stereoisomerism, so the cis trans supposed to be come into the middle. So A shows this double one supposed to come to the middle. Then the other possibility. There are two other possibilities, either this to the end and then breaking this CH3 and joining here and make it cis trans ahead. This one even doesn't have cis trans. Bromination followed by dehydrobromination, ABC forms DEF. D and E are isomers, but F is not an isomer. Okay. 2 bromine and removal of them, triple bond, and then triple bond here. And what happened at the last one is, once you join 2 bromine, bromine here and bromine here, and this this bromine gets away with this hydrogen. But there is no hydrogen for this blue bromine to get away, so that the blue bromine is just existing as it is. These are the structures. Again, same sort of table. Question number 62B1. මෙතන මේ කියලා තියෙනවානේ active species කියලා here. They talk about something active species that actually is electrophile or nucleophile, which is attacking. The active one was attacking. Okay, active species. It's just deuterium. You have to draw both. Either deuterium can replace or the other side can replace. So you're going to draw both. Electrophilic substitution, NO2 is the electrophile. This one, again, electrophilic substitution. Either, they were given marks for both these, but I recommend the top one because CH3 cannot exist itself because it's unstable. And OH, ortho-para. But in new syllabus they say Friedel-Crafts reactions are not possible for phenol, if you remember. Remember? Okay, FeBr3, again electrophilic substitution, Br plus is electrophile. Ortho-para positions. We're going to show both. NaBH4, this part is just existing as it is. To convert this into CH2OH, you need lithium aluminum hydride, but they were given sodium borohydride, so that only reacting on this CO to convert. Sodium borohydride is acting on carbonyl to convert it to alcohol. Here ketone, so secondary nucleophilic addition, Chlorine free radical CH3Cl. This is free radical substitution. It's 10:30. I thought you part I think it make a finish. Consider this, and they want to fill this. Okay, what happened here? Final one is C6H12O6, C3H4. Initial is make a deal, it make a when up nan, alkyne hydration, and then aldol. How easy. Z, they want us to name 4-hydroxy 4-methylpentan 2-on, or 4-hydroxy 4-methyl 2-pentanol. Both are okay. Don't break it. Just relax and have move and another party as well. It's okay. Happy 62 and 63. Let's do after the break. Fast and honey, not to cry. Are you guys okay with this speed? Understanding nicely? Okay, so after the break, let's move on to the next question. Okay, I know I am not expecting anything from you guys, rather going through this path with all these 3 subjects, but if you have a little time and if you know somebody, just give them the message, because you guys know this big attack is always coming. I don't know what is the reason. මේක උඩරම දාන්න පුළුවන් ළමයි 150යි අර ළමයි 10 ගණක් ඉන්නයි මන්ට තේරෙන්නේ නැහැ ඇයි එහෙම කරන්න කියලා. Anyway, so just give your own experience to them. If you find somebody who's doing advanced level in 2028. Okay, moving to question number 63. Essential oils are really important after 2019, so you cannot care less about that. This is cinnamaldehyde is the main constituent elements in cinnamon oil. It has a following structure. This is the structure. Suggested test to show that cinnamaldehyde contains a double bond. Okay, double bond alkene at red brown Br2 water turns colorless. Cinnamaldehyde is reacted with lithium aluminum hydride. Cinnamaldehyde. Okay, lithium aluminum hydride, this part CH2OH. Make a but we didn't do any this kind of reaction. So don't get a reaction attacking that lithium aluminum hydride onto double bond. We didn't do that. Okay. Name the type of nucleophilic addition, or this actually is reduction. From here to here, this is reduction. Also, they were accepting this word, nucleophilic addition. But reaction is occurring. Reduction reaction is occurring. So just write both together. Then you're going to get perfect marks or maybe bonus marks. Cinnamaldehyde reacts with isopropyl magnesium bromide. Give the name of a solvent used: dry ether or dry tetrahydrofuran. This one with oxygen, 4-carbon oxygen cyclic. Why it is important to have the solvent dry? It is unstable, it's polar solvents, accept H plus from water and converting to alkane. ඊට පස්සේ මේක දැම්මම මේක ලියන්නලු. So whatever the part, this greenard part is, this carbon is attacking onto this carbon. So that if you are just drawing this 4-carbon part is this part, and then to this greenard part, and that is this part. mineralization reaction that occurs between two molecules. Between two molecules they are asking. Then to make this one molecule, if they say they are using two different molecules, then you have to give two different molecules. Making here then a make a. Could you get the answer? Cinemaglide. So you're going to break from here. Done. Did you guys bring will we be able to finish this one? Do you guys bring this 11th unit? Let's see. The two compounds A and B have the same molecular formula. Both A and B react with Brady's carbonyl. Orange precipitate. A reacts with HCN. Okay. A reacts with HCN to form a single product C. B with HCN. Okay. Two identical. So that this is supposed to be A. Then from A you are getting C. But from this one you are getting this chiral carbon. So B gives then D and E. State the specific type of isomerism shown by D and E, optical isomerism. State a physical property that can be used to distinguish between D and E. Rotation of plane polarized light. Rotation of plane polarized light. What difference is shown D and E respect with physical property? Rotates plane polarized light in two opposite directions. Rotates plane polarized light in two opposite directions. See how they are expecting the answers according to the marking scheme. Such incidences get as kind of a theory, memorized kind of a theory as. Okay, done question number 63. Moving to question number 64. Benzene Friedel-Crafts acylation. බලන්න අපි ඒ කාලේ very simple කියලා we learn about all these from the beginning. Luckily you guys were at the class like all the time. You guys caught this organic really beautifully, but very easy equations now. How frequently they are asking questions. To reach, even for me, my attitude about chemistry is even to reach 75, 80, 85 is easier. Even 90 is not that difficult. Hardest part is to reach from 90 to 100. That is the part they are making like couple of questions that only couple of students can do those. But trust me, my personal experience of my students usually more than 50% of my students usually do that. So my best group එක දැන්ට ඔයාලා disappoint me. 21 is like, you know, it's a different story. But I guess you guys going to be my best group. But at 20, my 24 එකේම දැන් ජනේ top 10 වලින් කට්ටිය වැඩිනේ. But එහෙම නෙවෙයි ඔයගොල්ලන්ගේ ඔක්කොම නෑ. So the Friedel-Crafts acylation, electrophilic substitution, and then you have this negative charge Grignard here. So the nucleophilic addition. Okay, once you get COCH3, COCH3, then nucleophilic addition of this CH3 gets here and MgBr gets here. Once you add water, MgBr gets away, OH joins, and it doesn't matter if they have written this diluted. It doesn't matter because there are no any other reaction to occur because you are having already OH. So what only possibility is to getting away this water molecule, dehydration. And then they are just asking S, AD, S and E. Okay, we have two rearrangements, not here. We did two rearrangements. If you want, you can write that. Number one, ketoenol. Ketoenol during alkyne hydration, and then the other rearrangement is 2,4-DNP carbonyl reaction, nucleophilic addition reaction. We have two rearrangements that we explained in our syllabus. Ketoenol transformation and the reaction between 2,4-DNP and carbonyl. Okay. Active species and what is electrophile, whether it's electrophile or nucleophile. Okay, now not only the sketch they are giving, but also they are giving us reagents. Now things are getting little tougher. Okay, but it's easy. Initial compound has 2 carbon here, 2 carbon side is there, and then other side also has 2 carbon here. And then again they are showing here 2 of them together makes this one. If you break this is supposed to come between carboxylic acid and, so this part, green part supposed to come with the carboxylic acid, and then the pink part supposed to come with the amine. So this part is amine, but directly they are not using the carboxylic acid. Then the other option is the acid halide. So that this is supposed to come through the acid halide part. Then convert it to amide with ammonia, and then reduction to give amine. Those two together makes this amide, substituted amide. How easy? Okay, next one. This is the final product. Most of the time, like 95% of the time, you have to break ester. There are very couple of occasions. If you are not, the last step is the ester, but almost all the time last step is the ester. So I'm going to break from here. Then I have C2H5OH. C2H5OH. They were given that part. That part is they were given separately, so that you can add that. That is there. And then the other part we're going to make it. To make it, orthopara, COH and NH2. So I'm going to start something with orthopara director, that is the toluene. They were given this toluene. So that I'm going to start from that toluene. And then this is, since this is orthopara, NH2 you have to get directly. So you're going to start from going to NO2, convert it to NH2, and then you can convert this CH3 group here to COOH. And then esterification, the last step. You can swap these two. There are no interactions even if you swap these two steps. Okay, initial compound is given. Sodamide is adding with two terminal alkyne, and then sodium is joining here instead of this hydrogen, and byproduct is ammonia. They were not asking, but if you have enough time, just go with that. And then adding benzaldehyde. So the reaction type is with respect to benzaldehyde, it's a nucleophilic addition. Okay, benzaldehyde, this is the benzaldehyde part. Benzaldehyde part. And this part is this. And then they did two different stuff, and the final result is this one, CO, CH2, CH2, CH3. After doing two different stuff, they are coming here, and there is no double bond, and then oxidation. So oxidation comes later, otherwise this also can oxidize. So that just to save this one, first hydrogen nickel, then after that you are oxidizing this one to get here Br2Fe. This is meta-reactor, so for meta-precision you are making one single bromine here. So it's 6 hydrogen nickel, you cannot swap these two. PCC gatta puluwa. If this is PCC, you can write PCC here and then CO this part, and then later you can add hydrogen nickel. But if you go with acidic NO4, then you have to add at the last time to avoid oxidation of triple bond. And the reactions, these two reactions, reaction 1 and reaction 2. Reaction 1, acid-base reaction, because here the sodamide is acting as the base, and we have this acidic hydrogen here. So this is acid-base. And the last reaction of addition of this substitution of bromine, so it's electrophilic substitution. CH3Br made them make a kinone thus saying this one. KX gotten away, so they are making this RCN here, same way. NABR gotten away, so they are making this compound, CH3, C triple bond, CCH3. AC never everything is AC now. Okay, just to convince you guys how they are given marks for these, I have written marks here. Otherwise, if you have done this separately, still it is okay. So, but I have added everything together, okay? So, only this compounds are using to make. They were given only this 2 carbon. So, the 2 carbon, then 2 carbon, and then again 2 carbon. Okay, so the last step is to go with the esterification, so that we're going to start one side from this alcohol part, then other side supposed to come with this carboxylic acid part, Okay, again, carboxylic acid is okay, very obvious. You can just go through this oxidation, it is there. But then again, you're going to make this 4 carbon compound plus having this OH group. So the best possibility, one of the best possibility for all 4 carbons are joining together is going with carbonyl and Grignard, because carbonyl is already given. So we can make the Grignard, CHO to CH2OH, CH2Br and CH2MTBr. Once you make the Grignard, to that Grignard you are adding same carbonyl. To Grignard you are adding carbonyl to make alcoholic part. Alcoholic part. And then see, On all, see how they were given marks here. Let me explain you how they were given marks here. Making sodium borohydride දාලා CH3COOH on the main 3 marks. Making acidified any oxidizing agent දාලා making COOH, so another 3 marks here. Understood? So make I method use කරනවා to make the alcohol, then again another 3 marks. So either you have to show like this, or either you write these equations separately. They have given marks one by one, step by step. Making this one 3 marks. Understood? This one is a precursor of this reaction. This one plus this one, making this one, you get 4 marks. Same another. Making this one 3 marks. This one again reacting with this one, you can get 4 marks for this one. Clear that? Okay, every step, yanna maximum determine කරගන්න. Sort of the same kind of I don't see here. Full of weak and full of strong students. Okay, so make benzene වලින් start කරලා තියෙන්නේ. You have 2 carbon. ඉතින් මම benzene එක 2 carbon, if I separate this part, then the remaining part, you guys know this, whatever the R group, you can go with this oxidation to get CO. This is supposed to be the other side. Then from one side, we're gonna and මේක එකට එකතු කරලා තියෙන මොකක් නිසාද? So addition of these two comes to the pre-Craft acylation. So the one side you're supposed to convert this into acid halide, and then the other side is the benzene. Other side is this part, only this part, that is this. Okay, so what we're supposed to make this acid halide part, COOH, and then it is also having this NO2 group, meta, I'm just adding NO2, and then this COOH converting to COCl with PCl3. And then these two together comes to the final product. How easy. Okay. Part එකක් තියෙනවද that we need to do something. Moving to question number 66. Okay. This part, aniline, is here. So that newly added part is this COCH3 part. And then to that, they were adding this NH2 group, NO2. And then add sodium hydroxide. Once you add sodium hydroxide, what happens is sodium hydroxide hydrolyze this COCH3. Then you are going back to this nitroaniline. Low temperature. Now we are going to convert NH2 to N2Cl. Then you have chlorine here. That is a Sandwich reaction with CuCl. Finish. Chalaya. L and M විතර ඇහලා තියෙන්නේ. No. All asking for here. Okay, so X, Y, Z and L and M. How is it? Again, you have same kind of a conversion here. Okay, again you have, they were given the table, but still, this part is the ester part. So I'm going to hydrolyze to get that ester part, this part, the carboxylic acid part. And then the other side you have this alcohol part, and that is this part. Okay, so I'm going with conceptual 4. Then this 3 carbon part is again, you guys can see here. 3 carbon part, 4 carbon part. 4 carbon part you guys can see here, and this 3 carbon part you guys can see here. Double bond, before double bond there can be OH, and this is supposed to come through Grignard. Let's see, because they were given Grignard. Sodium hydroxide is given, but this is not aldol. You can go through aldol. You can try it, but it's not giving the answer. So that the red part. Okay, carboxylic acid, reduce CH2OH, and then the bromine, and then magnesium triether, Grignard. And then the other side, oxidizing, and then Grignard and carbonyl gets here, remove the water, so you are getting double bond here. Honey, all are correct. Did you do this? Because you didn't try or you couldn't do. Okay. If you tried, easy. Yeah. Maybe make a easy. So this one, what is this one? This is an imine compound. This is an imine compound. So the main part again, make a one part comes like this, and that's supposed to be then come through this ketone, and then the other part coming from this, and that is this aniline. So the reaction between ketone and aniline. Okay, aniline you cannot make like here. They have one single step here, one single step connection here. So this is supposed to be aniline, because this one doesn't make aniline. So this is supposed to be aniline. On the other side, you're gonna make this 4 carbon carbonyl compound. 1, 2, 3, 4. 4 carbon carbonyl. 2 carbon triple bond Lindner hydrogen double bond HBr bromine. 2 carbon here, and then the other side is supposed to be, they are making another 2 carbon with sodium acetylide, because sodium also given, sodium acetylide, add them together. Remember, make a digger. They were not given space to write anything, and they were not asking this one. They were not asking. Magnesium dry ether, you can get here at PCC, and you can get here as well. 8th step ready. Methanol reagents, they were not given marks or they were not given space. Moving to question number 67. We can more English because there is this explanation. Question 17. Okay, this one. A, B and C are 3 isomeric hydrocarbons with the molecular formula C7H14, CnH2n, so these are alkenes. Compound A shows geometric isomerism. So, carbon hatak තියෙනවා geometric isomerism කියන්නේ cis trans, just make sure that there are cis trans for A. While compound B and C, they don't. B and C, they don't have cis trans. optical isomerism, they all are showing optical isomerism. On catalytic hydrogenation, all three compounds yield compound D. Okay, one single compound coming from all these, once you go through this hydrogenation mean, they all three supposed to have same skeletal structure. Compound D also show optical isomerism. Isn't how beautiful this data. Okay, D වලට එකම skeletal structure and they say මේක අපි කලින් කරපු එක වගේම වෙනසක් නැහැ වගේ නේද? Shows optical isomerism. So I'm going to start from that. Optical isomerism. So the middle carbon, then 1 carbon, 2 carbon and 3 carbon. So this is the skeletal structure. They say one is showing cis trans. To show the cis trans, everyone is supposed to get to the middle. And then since other two are not showing cis trans, those two are supposed to go to these two positions. One here and one here. So one here and then the other one here. Very easy, extremely easy. On treatment with bromine followed by dehydrobromination with alcoholic KOH, A forms two compounds E and F. Anything on a neither. So both sides are actually same number of carbons are here, but bromine දෙක මෙතනට එන්නේ. So if both bromines get away with both hydrogens of same, then you are getting a triple one here. But otherwise, let's say one HBr is getting from here and the other one is from here, then you are getting these two bonds. Okay, let's say this one bromine, one HBr gets from here and the other one gets from here, then you are getting double bonds like this. If it is going from this green place in between two bromine, then you are getting this one. And then while B forms two compounds E and F, while B forms compound G and C forms compound H, yeah, B forms D, C forms H, and A forms these two. A forms these two. Compound E shows geometric isomerism. Yeah. Compound E shows geometric isomerism while F, G and H do not. Compound E. Yeah, this one here. This one here. This color is showing this geometric isomerism cis trans. Others, there are no. There are no. Clear? How beautiful these answers are. Moving on. F and G alkynes, but G is terminal alkyne. You can use any of these identification of terminal alkynes. Only G gives white precipitate with ammonical silver nitrate, which F doesn't. Only G gives red brown precipitate with ammonical CO2Cl2, but not by F. But not by F. You guys have to say that. And then this is clear, I guess. Okay, this is meta director, so join it to the meta position. Anyway, electrophilic substitution, HBr addition, electrophilic addition, HCN or KCN, it is same actually. Nucleophilic addition, alcoholic KOH goes always with what? Elimination. KCN, iron gets away, CN minus joins, nucleophilic substitution. Easy. Okay, 68. See, now we are moving to modern questions, but you don't feel these are difficult. You don't feel these are difficult. 68. English medium. Okay. Compound A exhibits optical isomerism, has molecular formula C7H16. Possible structures you can just draw. The very first step, hydrogen, 1 carbon, 2 carbons, 3 carbons, or otherwise one of the carbon. Okay, getting very slow again. And 1 carbon, 2 carbon, 3 carbon, one of the carbon can detach and join it onto this middle carbon, and there is this one. So you have two structures. State the isomeric relationship. Okay, so only the structural chain isomerism chain. Just write both. Structural, part of structural, but specifically chain isomerism. B and C are optically inactive compounds with the molecular formula C7H14. Both B and C exhibit geometric isomerism. B and C are not geometric isomers of each other. Okay. C7H14, so that is alkene, CnH2n. මොකක් හරි එකක් අඳින්න පුළුවන් ඕන මම නිකන් එකක් ඇඳා no optical isomerism mean it has to attach to this middle carbon. Then possibilities are these two. The double bond is in between 2 and 3, or double bond is in between 3 and 4. This double bond is in between 2 and 3, and here double bond is in between 3 and 4. This actually is the A. This actually is the A. Same A. Yeah. And they want us to name this B and C. It's okay, darling, I'm ready. Three methyl hex 2-ene, 3 methyl hex 3-ene. B and C. 3 methyl hex 2-ene, 3 methyl hex 3-ene. It passes. So the next part, you have this double bond here, addition of HBr, Markovnikov, bromine gets here. This is one, this already had. It doesn't matter. It doesn't matter for us. This bromine, let it be there. Alcoholic KOH, now both these bromine gets with hydrogen, so that you are coming here. Sodium nitride liquid ammonia, sodiumide liquid ammonia mean we are making these actually sodiumide, if you remember for inorganic chemistry, 2 sodium plus 2 ammonia gives 2 sodiumide and H2. This is one of the inorganic question. So that this terminal sodium and then addition of alkyl halide gives this chain extension. Reaction 1, 2, 3, 4. Reaction 1, electrophilic addition. Electrophile is H plus, and then the double bond breaks, so it's definitely electrophilic addition. Number 2, elimination. Sodiumide reactions are acid-base reactions, now you guys know already. And the last one with respect to our initial one is this. Our initial one is this here. With respect to this one, this is nucleophilic substitution with respect to alkyl halide. Nucleophilic substitution. Acid light ion is a nucleophile. That again we done already. See, they are just continuously asking this. Draw the structure of a product T obtained when reaction 1 is carried out in the presence of peroxide antimarker. It has been found that T is also formed in reaction 1 as a minor product. By considering the mechanism of reaction, explain why the major product of the reaction is P and this is P. This actually is P. So here I will now run. Yeah, he is from first shy. Everybody is in his same batch is second shy or third shy. I mean almost everybody. First shy yana hari anu darwane. Maximum kadikana. Sir hidu karayda. Set kena balance වැඩක් නැහැ නේ අක්කලානේ. මම මේ 26 set එක එනකල් වෙන්නේ. 25. 25 set එක. නෑ මේකට 26. Okay, so this is P. So get one markam ඉවරයක් වෙන්නේ නැහැ. ඕගොල්ලෝ දිහා ඔයාගේ මන markam ඉවරයක් වෙන්නේ නැහැ. මේ මේගොල්ලෝ දිහා hina වෙවි කියලා තියෙන එක මතක් වෙලා. එහෙම තමයි ඔයගොල්ලෝ පුංචි ළමයි වෙන්නේ ඇඩ්වාන්ස් ලෙවල් ඉගෙනකන් විතරයි. ඊට පස්සේ ඔයගොල්ලෝ ලොකු ළමයි. කොහොමද විලක් කරන්නේ? දැන් ඒගොල්ලෝ ඒ ගිනෝ දයම ඉතින් ගානක් නෑනේ ලැජ්ජයිම නෑ. ඉතින් ලැජ්ජ වෙන්නේ නෑනේ සර් එක්ක ගොඩක් ෆ්‍රෙන්ඩ්ලි නේ. ඔක්කොම විස්තර කියනවා. ක්‍රෂ් තිබුණාම කියනවා. ක්‍රෂර්ස් කියන්නේ කියනවා. Okay. Make it answer P intermediate of P. You're going to show this secondary carbocation. That's the secondary carbocation. And then intermediate of T. Intermediate of T is primary carbocation. Here in secondary carbocation, both R groups connected to C plus push their electrons towards C plus and hence stabilize it by inductive effect by increasing electron density of C plus. Here in secondary carbocation, both R groups connected to C plus push their electrons towards C plus and hence stabilize it by inductive effect by increasing electron density of carbon. Even inductive effect is possible. Primary carbocation is not stabilized by its electron density. Therefore, through more stable secondary carbocation, the reaction occurs. Hence, P is major product. Perfect. Final answer. Moving to 69. A and B are structural isomers of methyl pentene. අපි methyl pentene ගැන දන්නේ නැහැ. අපි ඒක නිසා just එකක් අඳිනවා. එක methyl pentene එකක් ඕන මම අඳිනවා. Methyl pentene කිව්වොත් එහෙම they are supposed to be a double bond. One methyl group somewhere and somewhere double bond, somewhere methyl group. Just this kind of a structure. අපි හිතමු මේක උනායි කියලා. So it can go to either this way or either this way. This is the methyl pentene. Okay, these two are the possible structures. This top one and this bottom one are the possible structures. Molecular formula is C6H12, so they are just continuously saying they are supposed to be double bond. A exhibits geometric isomerism while B exhibits optical isomerism. Okay, A will geometric isomerism, B will optical isomerism. Okay. If this is the structure, double bond is supposed to come in between the first and second carbon and methanatide. So make it no cis trans. Make it this has cis trans and here no cis trans. But any of these have no chiral carbon. So make a when ban either. After cis trans chiral. So this kind of big structure. So that mama make a structure. So that this actually is supposed to be the structure. To make a structure double bond method either here or here. So chiral carbon is just existing. If we move the double bond to this middle chiral carbon, there is no chiral, then cis trans. And these two together, if you go through this hydrogenation, getting back to same C6H14, and this is optically inactive. So, may the structure make a but no cis trans and no chiral here. No cis trans, no chiral here. So that when structures. I told you guys isomerism was a very little part, but always there is a initial part of any question coming through this isomerism. Okay. This one again. A and B. Okay, A and B. So these two are A and B. Both we are adding antimarconic here. So hydrogen goes to your hydrogen is high. Sorry, hydrogen is less. So this is a place where they are getting hydrogen. D and G. So this is D and then this is D. I mean, this is extremely slow today. And this is D. This is D and this is G. And then KOH at aqueous KOH, bromine OH, that's easy. And then PCC, this is giving ketone, but this is giving the aldehyde. Ketone and aldehyde. Remember, any identification test you can go with, because F is a ketone, sorry, I is aldehyde. So in the mirror, failings, tolerance failings, acidic KMNO for acidic dichromate. You can write tolerance, you guys know that. You have to write monomer nitrate, okay? Don't write as tolerance. Okay. And then the next part. This. I'll show pointing at the screen because it takes time to draw it. Okay, double bond. Bromine break the double bond. One bromine become electrophile, so electrophilic addition. Joining this meta-director, Friedel-Crafts acylation, electrophilic substitution, OH to Cl, nucleophilic substitution, any dehydration, this is dehydration, and its elimination, nucleophilic addition. See, make it, they were not adding acid or water. So you can stop from here. Remember that. If you have written OH here, no marks. Make sure. and Mikasa. බලන්න චූටි වෙනසක් තියෙනවානේ. That is the only difference because you supposed to get with this merge with this CHO and then definitely you supposed to join this whatever the group to this carbon or either this carbon. එතනින් එහාට ටික normal. So මේ carbon එකට join වෙනවා නම් so you going to give this electron to this carbon, then you are getting plus charge here. Then you are getting plus charge here. And මේකත් අඳින්න ඕනේ. Okay, this instruction is if they were asking for the rest of the part, if they were asking stability using this intermediate, then you are drawing it separately. Let's say inside the question they were not asking what the stability of the intermediate, but still you are drawing all these. That is the solution. Whether they are asking or not, just draw these intermediate these structures. Form intermediate carbocation gets stabilized by delocalizing of positive charge with benzene ring as shown in 3 resonance structures. Question number. ඔයගොල්ලන්ට questions කීයක් තියෙනවද? මම හිතන්නේ මට මේකේ questions අඩුයිද තව එකක් තියෙනවා. How many questions I have added to your table? Yeah. මට තියෙන්නේ මේකේ questions කීයද? මේ last question එක 70. 1. 72 මොකද්ද? 2017 එකද? නෑ. 70. 2016 මට පේන්නේ 2016 ආදී නැති. Okay, moving on. Moving to question number 70. A, B and C are structural isomers with molecular formula C5H11Br. මොකක්ද එකක් ඇඳලා බලන්නකෝ C5H12 වුණොත් alkane, so that is supposed to be a saturated alkyl halide. Just මොකක් හරි ගන්න නිකන් ඇඳ කියලා හිතන්නකෝ ඕනි දැන් දෙන්න. All 3 exhibits optical isomerism, so definitely you can start from this. Make it start with optical kinetics. So the one hydrogen, one carbon, one the other active part, and all the other lines here. It was say make one of this carbon you can detach one of the carbon, then you are coming here. Any other possibility, then that carbon you can join here. Instead of Br, you can make CH2Br. ABC gives DEF. So ABC going through this path plus this path is important. So A gives D, B gives E, C gives F. Respectively with alcoholic KOH. So that's double bonds. ABC को एक दिखेगा decide करना है eating for now. So we can go with this one, and this one. Okay, and then DEF. D exhibits geometric isomerism. Geometric isomerism. Make it one. Oh, make it right. So D comes from A, so this is supposed to be A, so this is supposed to be D. So we're going to do this on a scratch paper, then we don't know which one is A, B and C. Now we know since this is D, this is trans, this is supposed to be A. E and F no geometry. Okay, how do we distinguish E and F? When react with HBr, E and F gives G. G is a structural isomer of all ABC. G is not showing. Anything gonna is in gonna name. Okay. Out of these two, if you try this adding bromine, you are come to same G. Make it hydrogen goes to the hydrogen is high, then bromine gets here. You're gonna get the same product. B and C unable to distinguish. But if this is B, then this is supposed to be E. If this is C, this is supposed to be F. Understood? Okay. Mama Media, I've just put them here because then I don't have to go back and forth to explain because the answer, that box is in the other side. Base reagent, this is H, base reagent, 2 OH groups running here. Chlorine gets away iron joins, potassium iodide, triple bond to double bond, hydrogen palladium, barium sulfate, quinone in J. And this one, COOH is saving, only this CO is converted into CHOH, sodium borohydride. See, the lithium aluminum hydride reduces both CO and COOH. Okay, OH, COOH, cold acidic KMnO4. Remember, we are writing cold for potassium permanganate because it's dissociating with temperature. And this one is the elimination or dehydration. This is this as replacement, substitution replacement. Hydrogen gets away and copper joins. PCl3, OH to Cl. CONH becomes CH2NH2 with lithium aluminum hydride ether reduction. This is Friedel-Crafts acylation. CH2COCl and hydrous aluminum chloride. And then this little mechanism, sodium hydroxide gives OH minus, which is the nucleophile. So the first step is a nucleophilic addition, and then this oxygen needs to come back to make this double bond. So that chlorine gets elimination. So the final reaction is nucleophilic substitution. Cl gets away, ONA joins here. Question number 71. A, B, C and D are structural isomers with the molecular formula C4H10O. C4H10O can be alcohols and ethers, and reacting with sodium to release H2. So this is alcohol, not ethers. And then they say A exhibits optical isomerism. So you can try A. One hydrogen, one carbon, two carbon, remaining is OH, or otherwise one hydrogen, one OH, one carbon, two carbon, whatever the way. So this A is already, you can confirm. B, C, D. B instant turbidity. So you can decide B as well. Okay, one carbon. So tertiary part here, OH. So nothing remains. So this is then B. Then we are moving to this side, C and D. Okay, 4 carbon, other two isomers are these two. Which is which? I just keep asking you guys to draw this kind of a, like A gives I, B, then C gives J, C gives E, D gives F, D gives G, and F gives H. So you guys need that kind of a little, like, the sketch while going through this path. C and D are very slow, mean both supposed to have CH2OH. So these are the only possibilities. C and D were heated with concave SO4 EF. The concave SO4 on EF N. both have C4H8, they say that no geometric isomerism. Nine make a same to CH2, same to CH3, same to CH2, and E and F gives with HBr, D and H. G exhibits C. When G get in isomerism, who is G? G comes from E, E comes from C. Now you know all. The quote. Who answers here? Okay. Answers. At the exam, make sure you are doing even a single bit of mistake. Hold on. This. HBr, peroxide, hydrogen goes to where hydrogen is less, bromine goes to the terminal. Number 2. 2 for DNP, you're going to draw this. It's a must, you're going to get the practice. Beta naphthol, we have this practice as well, red dye with disonium. Acid halide, ammonia making amide, formation of amide. Clinocraft, electrophilic substitution of NO2 but to meta. And this one, zinc mercury complex reduction, Clemmensen reduction. And this one, silver amine complex tolerance. So the medium is basic OH minus. Either this one, COO or CH3COOH, both are accepting. So sodium reaction, hydrogen replaces with sodium here. Minus plus is a must. Minus plus is a must. Hydrogen palladium, just a hydrogenation. Adding bromine to this one, tribromo, white color precipitate. So it's easy to explain you guys when the reaction, product, reagents all are there. Because they want everybody to get through with all these 3 subjects. I know a lot of online kids are watching these videos. They want least for you guys to get 3 S classes. That's why they are adding very easy questions. Part of organic is extremely easier. That's why. Maka patangan mama kiwane the only moderate organic puluang enai kiyala. Katat organic puluang. Katat organic puluang welle welakata enama. Challenging part is inorganic. Most challenging part is inorganic. ළඟට කොහෙද? 17. 16 ඉවරයි. 17. 17 මගේ තියෙන්නේ yes. 17. I guess that's the last thing. What would you guys do? Up to essay part? Yeah. Give me a second. You're going to go with this part as well. While you are going with this kind of a sketch, go with that kind of a sketch as well. C5H12O, A, B, C and D are structural isomers. A, B and C shows optical isomerism. Draw possible structures for A, B, C. C5H12O, CnH2n plus 2O, those are alcohols or ethers. Ethers don't show this reaction, so we are directly going with alcohols. If you maintain optical isomerism, we can go with, we don't know which one is ABC, we can draw like these 3 structures. 1 hydrogen, 1 carbon, 2 carbon, CH2OH. And this CH2, You can just make it OH. Make it very first again. Hydrogen carbon, then all together carbon and then OH. Then you can break one of this carbon and join it here to the other side. Just break this carbon and join it to the other side. Then you are coming here. And then the other possibility is this one. This doesn't have any of these isomerism. No isomerism here, optical isomerism. Hi, ඔය ටිකෙන් එහාට BCD react with dichromate. So, within the dichromate reaction, CH2OH, COOH, this is secondary alcohol become ketone, secondary alcohol part become ketone, and then ABC what is the negative? XYZ. So they are making XYZ. XYZ are formed respectively. Product XYZ can be converted back to BCD respectively by reacting with sodium borohydride. Okay, so sodium borohydride में मदार लेना. Sodium borohydride no reaction here. XYZ. So other three are this ketone, and there are these three reactions. BCD, so that we can confirm this is A. Okay, then on A, we can separate it A. What is the structure of the A? They are asking that, so you can draw that. On heating with conc H2SO4, A and B gave E and F. Okay. A and B gives E and F, and this is E. This is E because E comes from A, and then B gives F. Respectively, while C and D gave the product G. Api kalla balamu kattiyatama, two of them supposed to give the same product. Okay, so this one gives this one, and these three. If you go with this, if you make this straight, 2 carbon double bond 3 carbon, 2 carbon double bond 3 carbon, same G, then මේ දෙන්නම් තමයි C and D වෙන්න ඕනි. B is, this is different, so this is B. Now we know A, now we know B. Then from A to D to H, B to F to H, A part G shows diastereomerism. G, honey, sisters. All three compounds E, F and G have molecular formula C5H10. Yeah. When E and F are reacted with HB at the same H. E, you're making any F, so the same H. So this can give this product if you draw the straight line, and that is exactly the same. Yeah, the word. How easy. Guiding is really easier. Be like, go like, not being panicking, not being hasty, step by step. This one, and also you guys made this as well. Then very easily you can write answers if you have this little sketch as well. Okay, anyway, so these are the answers. These are all answers. If you skip questions, let's say you are too busy with other two subjects, then මොකක් හරි සබ්ජෙක්ට් එකට ගොඩාක් රෙකෝඩින්ග්ස් දාලා තියෙනවා. 15ක් 20ක් වගේ වෙන්න. එහෙම දැන් එහෙම ගියොත් එහෙම බලද්දී ඔයගලන්ට කෙමිස්ට්‍රි වල ටයිම් එක දෙන්න වෙන්නේ. Then you would feel like chemistry time is like there is no time for chemistry. But make sure always that you are keeping chemistry time for chemistry, okay? Rest of answers. So if you feel like time is not enough, just if you're gonna skip questions in the middle, not like the totally from, let's say, consecutive questions. Just in the middle of, like the irregularly miss questions. Don't miss questions like continuously. Then you are missing some sort of a exact part. Okay. And then Parachumana, Jamatika, Sistrans. Yeah, sistrans of E and F. Sistrans of G. Sistrans of G are these two. Second one, change the positions. And then part B. Yeah. Sodium nitrate HCl. So NH2 is converting to N2Cl, and then adding this one electrophilic substitution with respect to phenol, and then this one Cl2OH, sodium hydroxide, potassium hydroxide, any of these 8 pairs, and then PCC. See, now they are checking your memory. PCC, and then HCl cyanohydride. These are newer questions. Don't think like 17 in the 2026 like 9 years, but about 2012 have the same like priority. All are new questions, very newer questions. And then the reaction types are electrophilic substitution, nucleophilic substitution, nucleophilic addition to double bond. Okay. I think major product and then mechanism again. You right there. මේක දාලා නැහැ. මම මේක කොහොමද කරන්නෙත් නැහැ. 18 දාලා තියෙනවා සිංහල මීඩියම් එකට, but I don't do that. Because we're going to do all those papers separately. And then, so the next week, I'm going to post you guys this essay part as well. And then next week on, we are starting this chemical physics. Okay, bye. Take care then, everybody. Bye.